One of the most common applications of derivatives that we've seen is finding the equation of a tangent line, and that's what we're going to review and practice in this video. Let's recall that the equation of a tangent line of a function can be evaluated by using the following formula. So y minus y1 equals m sub t times x minus x1. And m sub t is defined as the value of the derivative of a function at x equals x1. Okay, so the way we evaluate the equation of a tangent line is we start by finding a coordinate point. That's what x1 and y1 are. It's a coordinate point at some point in the function. And then m sub t is the value of the derivative at that coordinate point. So you find the derivative and then plug in the given x value. The equation of a normal line is y minus y1 equals m sub n times x minus x1, where m sub n is defined as the opposite reciprocal of the slope of the tangent line. So the way we're going to write that is negative 1 over m sub t. So the process behind finding the equation of the normal line and the equation of the tangent line is very similar, except the slopes are slightly different. Let's go through some practice. Okay, so most of the questions we're going to see today are going to involve finding the equation of the tangent line up here, and then we'll see a question at the end of this video involving the equation of the normal line. So let's start with a kind of a trickier example. All right, we are given a function, f, and we are given that f of 0 is equal to 5. And we're also given the derivative of this function. We're given it here, written as an equation, and we're also given the graph of this derivative to the right. We want to find the equation for the line tangent to the graph, or the equation of the tangent line, at x equals 2. So we want to use this formula here. Okay. X sub 1 is going to be the value that x is on this tangent line, and that's given to us. That's going to be equal to 2. Okay, that comes from right here. The y1 value is going to be a little bit more complicated. That is going to be the value of the function at 2. Okay, the value of the function at 2. And the way we're going to find that is from this initial value here, this derivative, and then the fundamental theorem of calculus. So let's write down the first fundamental theorem of calculus that we talked about earlier in the year. And that is, if I have the integral from a to b of the derivative of some function, well, that integral is equal to the value of the original function at b minus the value of the original function at a. And what we can do here is actually solve this for f of b. So if I move the f of a over to the other side, f of b is equal to f of a plus the integral from a to b of f prime of x dx. And this second equation here is what we're going to use to evaluate f of 2. So we can find f of 2 by starting with a reference point, our f of a, and that's going to be given to us up here. So instead of writing f of a, we can write f of 0 plus the integral from 0 to 2 of f prime of x dx. This equation comes straight from the fundamental theorem of calculus. And this is how we're going to evaluate f of 2. So f of 0, that's given to us up here, that's equal to 5. And we're going to add to this the integral from 0 to 2 of e to the negative x over 4 times sine of x squared dx, because that's the value of the derivative. Now this is not something we know how to evaluate analytically without a calculator. So let's plug this into our calculator, this integral. So the value of the y value of this function at x equals 2 is going to be 5 plus the integral from 0 to 2 of e raised to the negative x divided by 4 times sine of x squared dx. Okay, and this is what we're going to plug in to our, this is going to be equal to the y value of our function. Okay, actually, let's just double check. I'm in degrees. I'm going to change that to radians. So that's not the correct answer here. Let's clear that. So we're going to take this and plug this in. So the correct y value should be 5.623. So that's going to be our y value down here. So that's y1, and now to find m sub t, we are going to evaluate the slope of this function at 2. And this is nice because we're already given the derivative, so all we need to do here is we're just going to plug in 2 into the value of the derivative. This becomes 4. Okay, and so let's plug this in. So e raised to the negative 1/2, or negative 2 over 4, times sine of 4 in radians. And we get negative 0.459. So that is going to give it, it's going to lead us to our answer. So the answer here, the equation of the tangent line is y minus y1, which is 5.623, equals negative 0.459, our slope, times x minus 2. Okay, and that's our answer for this example. Let's go through a practice question involving another equation of a tangent line. Okay, so here we have the graph of the derivative of f. And what we want to do is find the equation of the tangent line of this function at x equals 2. We want to find the equation of the tangent line of g of x. Okay, so we want to find the equation of the tangent line of g of x at 2. So let's start with just recognizing how we're going to find g of x. G of x is defined as x times f of x. Okay, if we know that x1 is equal to 2, okay, which it is because it's given to us, we can find y1 by plugging this in here for 2. So we're going to plug in 2 here and here. All right, well, f of 2 is given to us. That's 6. And so g of 2 is equal to 2 times 6, which is 12. So that is our y1 value. Now to find the solution to this question, we need to find the derivative, or the m sub t value at 2. In other words, we need to find g prime of x. Okay, if g is equal to x times f of x, g prime, using the product rule, is going to be equal to f of x, derivative of x is 1, times f, plus x times f prime of x. Okay, now let's find g prime at x equals 2. So f of 2 plus 2, f prime of 2. F of 2 is something we've seen before. F of 2 is equal to 6 plus 2. Now to find f prime of 2, we are going to use the graph that's given to us over here on the right. F prime of 2 is going to be because this is the graph of f prime of 2 is going to be the y value at 2. And so because the y value at 2 of f prime is -1, f prime of 2 over here is going to be -1. So we're going to, instead of writing f prime 2, we're going to write -1. Now let's evaluate the derivative of g at 2. So this becomes 6 minus 2, which is 4. And that's our m sub t value. All right, now we have everything we need to answer this question. So the equation of the tangent line, the general form is written like this. And so the solution is y minus the y value, which is 12, equals the slope, which is 4, times x minus 2. And that is our answer for this question. All right, let's do a practice problem set. So very similar question. We're going to find the equation of the line tangent to the graph of k at x equals 3 when k is defined as f of g of x. Okay. Y minus y1 equals m sub t. X minus x1. That's always going to be our reference point here. So x1 is going to be 3. To find y1, we're going to find the y value of this function at x equals 3. So I'm going to plug in 3 here for x. All right. K of 3 is equal to f of g of 3. G of 3 is equal to 6. So k of 3 is going to be equal to f of 6. Right here. And now f of 6 is 4. And so the y value, or the y1 value, is equal to 4. Now we have to find the slope. So y, I'll write like this, m sub t is equal to, well, we're going to have to find the derivative of the slope. Sorry, the derivative of k of x. So let's start by finding k prime. So if k prime is f of g of x, k prime is going to be f prime of g of x times g prime of x. And we're going to plug in 3 here for x, and that will give us the value of the slope of the tangent line. All right. Well, g of 3 is equal to 6. We've seen that before. So this becomes f prime of 6 times g prime of 3. F prime of 6 is going to be equal to 5. And then g prime of 3 is equal to 2. And so we end up with 5 times 2, or 10. And so the solution to this equation is going to be y minus y1, which is 4, times 10. So 4 times 10, our slope, x minus 3. And we can leave our answer just like that. And let's wrap up this video by going through one more question involving the slope of the normal line. Okay, we have a function here that's defined as x cosine of x over x plus cosine of x. We want to show that the derivative is the following. So we're going to take the derivative of this function, and then we're going to find the equation of the tangent sorry, I said normal before, but this is asking for the tangent line at x over 2, at pi over 2 comma 0. Okay, so the first thing we're going to do is let's take the derivative of this function by using, we probably want to use the quotient rule here. Okay, so let's start by using the quotient rule. So if y is defined as x cosine of x over x plus cosine of x. The nice thing about this question is we're actually shown what the derivative is. We just need to prove what it is. So let's use the quotient rule. So we're going to do low d high minus high d low. It's going to get a little messy, and then we'll try and simplify this. So the low function times the derivative of the high function. To find the derivative of the high function, we actually need to use the product rule. So this becomes cosine of x plus x sine of x, but sine is negative, so I'm going to put the negative here in the front. Minus high d low, so x cosine of x times 1 minus sine of x, all over low squared. All right, so that's the derivative. We need it to look like this, though, so let's try and simplify this a little bit. Looks like we're going to have to FOIL this, which is going to get a little annoying, but we have x cosine of x minus x squared sine of x plus cosine squared of x minus x sine of x cosine of x. So those are the first two terms multiplied together. Minus x cosine of x plus x sine of x cosine of x all over. The denominator will just keep the same. All right, so this simplifies nicely because these cancel, and so do these. And so I'm going to change the order in the numerator, but we end up with the derivative of this function being cosine squared x minus x squared sine x over x plus cosine of x squared. Okay? And then to wrap up this question, what we're going to do is find the equation of the tangent line. So that's the derivative. We want to find the equation of the tangent line at this point. Well, this is nice because it's already given us the y value and the x value. So all we need to do here is plug in the x value to find the slope of the function at pi over, part B, pi over 2 comma 0. So x1 comma y1 is equal to pi over 2 comma 0. Okay, now we're going to evaluate the slope of this function by plugging in pi over 2 into the derivative. So we end up with, we want to find the derivative at x equals pi over 2. So this is equal to cosine squared of pi over 2 minus pi over 2 squared sine pi over 2 over pi over 2 plus cosine of pi over 2 squared. All right, pi over 2 is at 90 degrees on the unit circle. When we're at 90 degrees on the unit circle, cosine is the x value, and so this becomes 0. Sine is the y value, that is 1. So we get 0 minus pi over 2 squared over, well, this becomes pi over 2 plus 0, so over pi over 2 squared. The pi over 2's will cancel, and we get negative 1 as the slope. And so the equation of the tangent line, y minus y1, which is 0, is equal to our slope, -1, times x minus pi over 2. You can leave your answer like that. You could also kind of simplify it a little bit. So this becomes y equals 0 goes away, positive pi over 2 minus x. And let's leave our answer like that. Okay, and so that's how we find the slope of the tangent line. If we wanted to find the slope of the normal line, we would just find the opposite reciprocal of the slope of the tangent line. Okay, that's the only difference.